Hi all. So today we are going to discuss about the different types of errors in measurement. So you know that we are following design thinking based approach in our college. So which has 5 stages: empathy, define, ideate, protocol, and testing. Okay. So error. What is the error? Error is nothing but the difference between the measured value and the actual value. Okay, so there are several errors that is occurring in your day-to-day life during measurements. Because of instruments, you'll be getting error, or because of the observation of the human beings, error may be caused. Whether different errors are there. So I'll give you a few minutes to discuss among yourselves regarding this error analysis and types of errors, and then we can share our points with each other. Okay, so you can start your discussion. Okay, I think you have completed your discussion. Shall we start to share the points? Who is going to tell about the empathy part?
Let me tell about the empathize part. First of all, in measurement, accuracy is more important. Before solving a problem in science or in engineering, we have to sort the errors. We want the accurate measurement. First, we have to see the what is the problem. What is the problem occurred in the person whose point of view using the system, and what are the small mistake affect the output, and how the user wants the accurate. For example, in hospital we want to calculate the heart rate of the person, and by false alarm, and it detects the wrong information. By this is very dangerous. So accurate is more important in measurement.
So next, I'm going to define the problem statement here. So first, we have to clearly describe what we are measuring and what type of error or uncertainty can affect the measurement. So this can help us how to handle or solve these errors. Mainly there are 3 types of error, like a systematic error, random error, gross error. Systematic error, it happens in regular and predictable way. This may cause problems in instrument like a poor calibration of faulty parts, and then random error. This may cause in unpredictable way, like there are any small noise or changes in the instrument or in the environment. Last one is gross error, which is made up of human mistake. So this may happen when someone measures the instrument wrongly or take the wrong value and read the instrument wrongly.
Okay, who's going to tell about the ideal part?
So let us share about the ideal part. This is brainstorming ideas. We can explore many errors correction based on the measured values. There are basic techniques involved here. First of all, we have used instrument error, and we can apply the instrument error algorithm and repeating the measurement to measure the average value. And last part, we can measure the values, or we can correct the errors and to smooth the noise. That's it.
So we have the prototype stages, applying measurement techniques in real-time systems. Error analysis become hands-on, building our own systems or circuits, and taking real measurements and recording data multiple times. And the important concept in this stages are relative error and zero error, and standard and deviation error.
So finally, testing. It is evaluates the accuracy and the validity of measurements. Test your system under the different conditions. First, to analyze the measurements of reliability and validity. Second one is to stimulate the edge conditions and check for the stability. Third one is to validate the error minimization techniques of works. So techniques for test. First one is calibration of standard instruments. The third one is error propagation analyzers. Example, you create error outputs of a high precision reference device. It is effectively reading differ the 0.2 volts. It indicates the systematic error can be corrected.
Okay, thank you for sharing your points. So to conclude with, So first you said about the need for error. So in every applications you're using many sensors. So while measuring the readings, there should not be any error. If there is a faulty reading, then the output will be mistakenly given. So it is very very important in emergency situations. So the proper output we should get. Okay. So analyzing the different types of errors and overcoming those errors are very very important in all the applications. So for example, if you measure weight of something, so when you measure in one particular machine it will show one weight, when you measure in another machine it will show another weight. So these are all because of the accuracy and precision of the instruments. Okay. So we have to maintain proper accuracy and we have to calibrate the instruments properly and we have to install the instruments properly and the human beings operating the instruments should be well trained. So all these things will avoid the errors or minimize the errors to in order to get a better output performance. Okay. So thank you everyone.
Thank you.